Hello, everyone. Good morning, at least good morning for me, good afternoon, good evening, depending on where you are. I'm ready with my coffee, and we'll get started right now. Just to give you a little bit of an idea, if you can hear me okay, let me know. If not, also let me know. And how are we going to do this today? This is an open session. The idea is that we get to know each other, that we can talk a little bit about data science and everything data science, for breaking into data science, transitioning into it, getting a job, learning, anything you guys want to talk about. So the way it's going to work is I will, if you want to join the conversation, just ask to join the conversation. I can have up to 4 other people join me at the same time. So I will be adding you, introduce yourself, and we'll just get the conversation started. Also, if you want to ask any questions, you can either join us in the conversation, or you can ask your questions on the chat, whatever makes you feel more comfortable. So let's get some people join us. Shruti, Pankaj, Mariam, and Sarina. Hey, Shruti, how you doing?
I'm doing great. How are you?
So tell everybody who you are and what do you guys want to talk about today?
I'll just introduce myself. Hi, everyone. I'm Shruti, and I'm from India, Chennai. And I'm currently third year college student right now, learning business administration, but as well as very really interested into the data field. So I started learning data science and data analytics. And right now I'm working as a data analyst in a company. So yeah, that is
Wonderful.
it from my side.
Oh, great to have you here. Mariam,
Hi, everybody. This is Mariam. I'm a UCR student in a data science, and I'm currently in Washington, D.C., but my school is in LA, and I used to live in LA. And I'm working as a consultant. I'm a business consultant as well, and for the past 10 years, that's what I do. But I'm looking forward to do the change, basically change my career and get more into data science.
wonderful. Great to see you. Sarina,
Thank you.
Sarina, just in case we can't hear you, but feel free to join in whenever you want. So, Shruti and Mariam, what do you want to talk about? This is literally an open networking data talk, so let me know what you're thinking, experiences, any questions you have, go for it.
Yes, actually, the question that I have, since coding was so new to me since like last year, because I started coding and getting my master in data science. Coding is so new to me. Another thing is just how do we need to start to be the data science? Like, now I know I've learned everything through my school, but I would like to know how I can do change and be successful in it.
All right, so that's a really good question. The thing is that when it comes to data science, there's a very common and usual misconception. Most people consider the whole data science thing that it has to do more with coding than anything else. And don't get me wrong, coding is very, very important, but it actually has a lot more to do with statistics and understanding how computers think. So it's very important to learn coding. I do generally recommend people start with coding for one very simple reason. If anything happens in the midterm and you decide that data science is not the right path for you, then you got your coding skill, and that's a skill that you can use in any industry that you want. But in general, if you want to break into data science, definitely getting a lot into statistics and into specifically into the mathematical models that are used to build all the machine learning algorithms, and trying to understand how computers think. There's a very, very, very good online course called CS 501, CS 401. I actually forgot the rest of the name. It's from Harvard. It's completely free. You can take it online on edX and on Harvard's own platform. And it'll give you a good idea of how computers work. It's like Introduction to Computer Science, and that'll help you grasp the whole concept of computers, and that'll help you become a better data scientist at the end of the day. Thank you, Morgan. Yeah, CS50X. That's the name of the course. If I say anything and then I forget something, feel free to ask me on LinkedIn, connect with me on LinkedIn and ask me, and I'll find the link for you.
I think I agree with Jack, because even when I started learning data science, the first thing, actually I didn't even knew the data science field, but for me the first thing was Python. I was learning Python and I was just learning programming as a language. That's it. I didn't know actually there was a data science and data analytics, something like that in the field. So I was started learning Python, and then after I learned the basics of it, I just don't know what to do with this. Like, I know Python, but what should I do with it? That's when I actually dig deeper and then find out what all the parts are there, and that's when I came to know like data science is also an option for there. So I think, yeah, starting with a programming language and then going step by step into the data science field is actually a really good pathway for it.
That's true, because I just jump into it without knowing basically programming and statistics that well. I'm coming from the engineering background, chemical engineering, but there wasn't that much statistics in it. Mathematics was, but statistics and programming, I was like struggling, and that's why I started learning both, and it was very challenging. But I'm more confident. But thank you. So I'm going to put more focus in statistics and try to just learn one, pretty well, and then jump to others.
Definitely, that's what I would do. I mean, statistics is actually a vast field, and it's becoming vaster and even more complex with all these new algorithms that are coming up. I see that Morgan had a question about data science journals. Wow, that's a really complex one to answer, because they're all over the place. I mean, new studies are coming up all the time, new algorithms, new applications, etc. Keeping up with data science is, I would say nowadays, don't try to keep up. Just focus on what you're enjoying, because there's so much out there. You're never going to actually keep up. I was talking with a friend of mine, Colin, a few weeks back, and he was mentioning, that he feels like he's treading water all the time. And I'm like, just get used to it. That's data science today. There's always going to be a new algorithm. There's always going to be a new framework. There's always going to be a new library for Python, for R. Things are going to happen very, very, very quickly. So don't freak out. Just focus on what it is that you're trying to build, what you're trying to do yourself. There is a tool for everything, and just try to specialize on whatever it is that you like, and whenever you find something new, that's the time to get in. But just to give you an idea, I think the GPT algorithm, which is one of the first transformers that came out from Google for natural language processing, came out like in 2016, and it's barely 2021, and they're already up to GPT-4. So again, even if you try to keep up, it's not going to happen. Just try to keep up in the tiny area where you're actually doing. And Google Scholar is a very good place to find a lot of the data science papers that are coming out. Python is such an interesting programming language, even though I'm still in the basics level applying for data science, but I feel it's easier to comprehend than when I started with C and C++. Yes, Python is definitely a lot more friendly than C or C++. They're still great languages. They're still very, very interesting. The software is high level, so it's very intuitive. Plus, it has the whole Python structure concept. And the most important thing, you don't have to worry about having to allocate memory. The one thing I always hated with C, and I could not even start to program anything with C or C++, is the malloc, having to allocate memory every time you put a variable or call a variable, and Python just fixes it for you. And trust me, there's so much more that you need to focus on. Plus, you can actually develop a lot of stuff with Python. So just focus on Python. If you really want to get into data science, focus on Python. If you want to learn some more, go for it. But right now, Python actually just became on the TIOBE index the #1 language. It actually surpassed JavaScript for the first time ever. So for now, focused on Python.
Jack, even I have a question.
Sure.
So if I'm learning data science and there's a roadmap going on. So what happens is when I just take too many courses, so I get really distracted. Like when I'm doing one course, I actually don't complete that course and jump into the next one. That happens with me a lot. Like I keep jumping into the next courses without even finishing the first one. So I think, so what I'm trying to ask is, how can you make your own curriculum? If you make your own curriculum, then you stick to that topic and then just learn that topic and then go for the next one, like through various courses as well. But like you'll just stick to the topic. So can you just tell me if you have ever made your own curriculum, something like that, and how can you make your own curriculum?
Yes, it's first of all, focus on what is it that you want to accomplish. Like, I mean, why do you want to learn something? Like, for example, you can either choose a specific subject. Like, for example, you want to learn about deep learning, and deep learning as a general concept, not the specifics of, for example, transformers or generative adversarial networks, but in general, and go into that. Or if you already know that there's a project or there's something that you want to accomplish, that's even better, because then you can actually start following a path that'll lead you to be able to build something that is actually useful for that specific something. Like if you say, well, I want to be able to predict house prices. Okay, then probably the best way to manage that at the very beginning is working with decision trees, learning how decision trees work, and then moving on to random forest, and then you can move on to some basic neural networks or even deep neural networks, depending on it. But you can take it step by step, and it'll help you actually learn what you want to learn. Like if you want to learn programming, figure out if you want to learn Python, if you want to learn Python and R, if you want to throw SQL into it, although it's not actually a programming language. But whatever it is that you want to learn, try to be very specific about what you want to learn or what you want to accomplish. And the way to do it is, set yourself a goal. I think you've been part of the 66 Days of Data
Yeah.
initiative by Kenji, and
Yes.
that actually helps you just stay on track. So you say, this is what I want to learn in the next 66 days, and just try to learn something about it every single day for the next 66 days to build a habit. Monica, you said something very, very important. You have to learn how to learn if you want to be on this field, and that will be the number one thing. Learning how to be very efficient at learning new things.
It's an endless learning cycle over there.
Plus, there's new things coming out all the time, and
Yeah.
it's just going to keep getting faster as more people join the field.
Yeah, exactly.
Hi, Zach. So I had a question about what you said about the curriculum. Can you hear me?
Sure. Yeah, perfect.
Yeah. So basically, so what happens is we start the course or we start one point, one subject or one topic, and then we start working on a project for that, and then we start trying on trying to implement it. We get to know, no, it won't happen this way. We have to do it some other way, and then we jump on to that other topic. So it's just like hopscotch from one topic to another. You keep on getting there, and we never get to like finish it completely, finish one topic completely. So in that sense, like the whole curriculum part, it feels that the number of resources are anyways vague, very vast inside on the network, on social media and all the internet. So how do we actually like keep track of it? Because at times you jump over to the next topic, you never come back because you're not using that topic again in the near future. So it's like until the next time you have to use it, then you'll learn about it.
Well, here's the thing. There's skills that you want to develop deeply, and there's skills that you don't really want to spend a lot of time on them, because it's going to take you, like for example, if you ever need something specific for a project, it's going to take you an hour to just go look at the code, search online, make the adjustments that you need, and then you're not going to need it for another 6 months, a year, or ever. So it's the hard thing is figuring out which are the skills that are going to be like the core of your abilities, and focus on developing those. Like, for example, if you want to get very good at programming, then actually get very good at programming, specifically object-oriented programming when it comes to data science. If you want to get good at statistics, then work on getting good at statistics. If you want to get good on a particular library like Pandas or NumPy, SciPy, scikit-learn, PyTorch, TensorFlow, etc., then go into that. And just don't do just one project, do several projects. But at the same time, if it's just like, if you're not going to be doing a lot of visual presentations, because that's not your path for whatever reason, then it's okay to learn a little bit of Matplotlib and Seaborn, or a little bit of ggplot and Shiny. But at the end of the day, those are things, as long as you understand the framework and how it works, you can actually just go online and search for the snippets of code that you need, because you're not going to be using this all the time. So again, it really depends on exactly where you want to fit, and focusing on the core skills that you want to develop. Data science is one of the first professions probably where you need to be, I don't know if you remember the phrase being a jack of all trades but master of none. In data science, you need to be a jack of all trades and master of most, meaning that you actually have to be very, very good at many things, like statistics, programming, understanding how machine learning works, depending exactly on where you want to be. So I can't tell you exactly what to focus on, because it'll depend on where you want to go. Because even today, companies and data teams are just beginning to figure out all the possible combinations of roles that are there. The data scientist is like a generic role, just like a data engineer, and but suddenly now we have data architects, data engineers, data programmers. You even have data storytellers, which are people that are very good at making visualizations and communicating. So depending on which path you want to take and what is it that you enjoy doing the most, there are different core skills that you want to master them, and then the other ones, just use them whenever you need to do, and don't stress out if you don't. For example, I still haven't met anyone that knows every single command for any library. Well, there's probably one or two people that know all the commands for a specific library, but generally you always have to check the documentation and make sure that what it is that you want to add. So don't freak out if you can't learn everything about everything, because it's never going to happen.
So like most of the time I also stress out when I'm not able to complete a course, and I'm like, I feel guilty that I took on the course but I never finish it, in that sense. Another point, like you said, like not everyone knows everything, right? But when we go for an interview for a job opportunity, if we're going for an internship or for a job, they expect us to know like everything. Like my point is, even the syntaxes are available online. You should not be like testing them on syntax. Like people can get confused between the syntax, because not everyone has learned only one single language. At points, due to nervousness, they can like get confused between C, Python, Java, because at some point of the time they learned that, and due to nervousness they got confused. So what is your point of view amongst like when someone is going for an entry level job or an internship? So like how to overcome that know everything point? Like you won't be knowing everything for sure, but how can we like divert the situation in such a way that the interviewer knows that you know your topics, you have knowledge, even though you do not know the answer to that specific question?
Well, there's two parts to this. First of all, on your side, whenever they ask you to do something on an interview, especially when you get into the coding part of most of these interviews, if you don't remember like the specific command, just tell the interviewer, I don't remember the specific command, but the concept is this, and this is how I would solve it. Go into pseudocode mode. It's being able to do pseudocode, just writing the instructions that you would give a computer, is actually the most important skill when it comes to programming. So whenever you can't answer the question because you don't remember the specifics, like for example, specifically how to do that slicing, but it would take you like 1 minute to check it out online and remember, tell that to the interviewer. Don't be afraid, and just walk him through the pseudocode. You know how you would solve that problem. Even if part of it is, oh, I would go check on Google because I don't remember the exact command or the exact method for this particular solution. On the other, that's for you. On the other side, there's a big issue when it comes to hiring data scientists, especially data scientists. Data science is so new that most companies really have no idea what it is that they're looking for. And again, they focus more on the programming side of it, which they shouldn't. They should probably focus more on seeing if the person has the statistics skills, if they understand the concepts, if they can actually work with data, if they can come up with good business questions, good hypotheses, because again, it's called data science. So you need to be able to build hypotheses and test them to see if they're true or not. And that's something that companies are going to get better as time goes by. But most companies still, they do not understand what a data scientist is, and their hiring processes are practically the same as the hiring processes for a programmer or a developer, which is wrong, and they need to change that. So that would be what I would do right now. And my experience with talking with recruiters is most of them are okay with if you can actually walk them through the pseudocode so that they understand that that they know that you understand how to actually do this, even if you don't remember the specifics. Most of them are okay with it. Some of them won't be, and honestly, if they want you to know everything by heart, that's probably not a company that you want to work for. But that's just my take on it.
Very useful. I'll remember that next time. Thank you.
Sure, anytime. Guys, remember, if you want to jump in the call, feel free. If you want to keep asking questions, I'm going to read some of the questions that we have. Again, feel free to jump in whenever it is that you want. I'll be happy to talk to you. What are the requirements to qualify for a data science job? Again, one of those very, very, very complicated questions right now. It has to do with, it depends on what industry you're going to go into. Like, for example, if a pharmaceutical company is looking for data scientists, they are probably going to want data scientists that come from a pharmaceutical or a microbiology background, you know, people that actually know the industry. So in general, it's very difficult to know exactly what the requirements are. But again, they're becoming more interesting as time goes by. They're becoming better at hiring. In general, you definitely need to know your statistics. You definitely need to know your math. You definitely need to know your coding. And you nowadays, you especially need to know how to do a whole data science project from beginning to end. You need to understand the pipeline, and you need to understand how to run from generating good business questions all the way to helping the team put whatever model it is that you build into development. I don't know how to pronounce your name, so I'm sorry if I don't introduce you, but go ahead. You're live. Okay, so more questions. How is your view on blockchain database? I actually have no view on blockchain database because although I do know a little bit about blockchain, I actually did practice a little bit on Solidity. I'm not keeping up with what's happening in the blockchain world. The whole concept of a blockchain database blows my mind and seems like it might be very interesting, but I do not know enough about it yet to have an actual view. So sorry about that. What would you say is the difference between data science and business analytics? A lot. Okay, look. I'll answer that question in a bit. Pankaj, go ahead. Welcome.
Hey, Jack. This is Pankaj. I work for IGT as a BI manager, and we are getting into the world of forecasting using all this stuff. So the question I have is, what are your thoughts about low-code packages? Do you think how much it is necessary to understand the nuances within those packages, or do you just, or it is more important to just care about the results, that the output, and whether if it's very close to, for example, what is correct, do you think that's good enough, or because I think I'm seeing a lot of discussions around statisticians versus the team who is building all these packages, and they are saying, hey, this low code packages are killing the actual statistics and stuff. So what's your thoughts on that?
Well, it's again, it's one of those very complicated questions in many ways, but in general, there are a lot of packages that are making it easy for people to run statistics. And I do know a lot of very, very good programmers and even data scientists that don't understand the statistics that well, but they know how to use the packages amazingly. I mean, they're probably a lot faster than people with a statistical background when it comes to using packages like SciPy, like scikit-learn, etc. And here's the thing: if you're talking about building models from, building existing models with existing data, something that has been done before by other people, these people are great at doing this. So that's not an issue. Will someone that doesn't have a big statistical background be able to build a new concept or a new way of doing machine learning or a completely new neural network? I doubt it. It's possible, but I doubt it. Because you do need to understand a little bit further in if you want to actually build something. But no, there is no, I mean, you could have a surprise. Somebody could pop up and suddenly be, understand how this works, not understanding the depth of statistics, but understands the tools well enough. And they're very good at building models. The biggest issue that I've been finding out is that there's a lot of people that are good at building models, but they're not understanding the data. And when you don't understand the data, you are going to build very bad models. And some of those models can be very, very bad for society. And the biggest example, and this is something that's always brought up by Serge Massis, who's brilliant at interpretable machine learning, are the algorithms that have been built to see if a prisoner should get early parole or not, should get out of prison early. The data that was used to build them is so incredibly biased, especially against minorities, that the results of the model, although the model is perfectly well built, it's a very, very biased model at the end of the day. So it's that's the thing. You can you can have a very good technician that is going to build an amazing model that works well and give you the results that you expect. But the problem is, if they don't understand the data, they're probably they could build a model that's damaging to your business and that's damaging to society. So, at the end of the day, I would say if you're very good at building machine learning models, just go into and learn statistics. Really, it's not that hard. It just takes time.
Yep. The problem with me is I'm on the both. I have a statistics background as well as not working in the initial when data science was not very popular last few years. So I'm on the both sides. So I just keep. Should I go into and look into exactly what this package is doing, and then I don't know. I mean, is it going to take too much time if it's giving me good results? So it's always, there is a fight between my left and the right brain. So.
Well, again, at the end of the day, all we can do is build models. And the big saying, all models are wrong. Some of them are useful. The question is, whatever models you're building, are they being useful, and are they going to be good in the short, long, mid, and long term? So, at the end of the day, that's all that matters. And again, what are they good for? Because then we can get into the whole ethics debate about, for example, Facebook algorithms that just push ads at you. They're doing their job, and they're doing a great job at it. Are they good for the people on the other side of the screen? And apparently they're not. So, you can get into the whole ethics debate, and that's a whole different level. But again, this is so new for everyone. This whole data science thing is so new for absolutely everyone in the world. It's going to take some time for us to figure it out.
Absolutely.
So going back to the question, what would you say the difference is between data science and business analytics? Well, well, for me, that's simple. Business analytics has more to do with figuring out what happened before, and trying to make decisions where they're trying to do a little bit of forecasting. Machine learning and data science has a lot more to do with building models, as we were talking right now, building models that are going to give you an answer and that you can keep training constantly, and that they get better with time, better at predicting, better at diagnosing, better at prescribing. So that for me would be the biggest difference. I mean, business analytics has to do with understanding business, having a little bit of background in statistics, and understanding how the business works, so you can actually try to make better decisions with whatever information you have. And data science has to do with building projects with the data that are going to help you in the future in many, many ways.
So can we say that business analytics is more about looking at the opportunities, and then the data science is the tool to realize those opportunities? And so I would say that both are interconnected, but I think business analytics comes where you realize those opportunities, and you think about what's the future of the company, what new things you want to add. That's called business analysis. But how do you get there? You have to churn through a lot of data, build models, and predict few things, or analyze the historical data is what data science is all about.
Definitely. And again, building plus here's the biggest thing. As a business analyst, you're going to use your knowledge and your business savvy. You're going to follow your gut instinct. As a data scientist, you're going to do science with the data and follow the data, not follow your gut. If it's telling you that your hypothesis is wrong, then your hypothesis is most probably wrong. Just look for another one. So that's also what's going to be a big difference. One does the science, the other one does the business. So here's another question. Can you get a data science job without a master's degree? Yes. And as time goes by, that's going to become even more common. Some companies are requiring master's degrees, even PhDs, because they have very high-end teams. But for entry-level jobs, and as time goes by, as there's more need for data scientists, there's going to be less and less companies that are going to ask for a master's degree. Is there an international society for natural language processing, like Operation Research has informed? I actually have no idea. I am not very. I do know a little bit about natural language processing. I like it. I want to get into it, but that's not my day-to-day job. Has nothing to do with natural language processing. So I actually don't know if there's an international society for it right now. Plus, if you look on it online and you just say International Society for NLP, you're going to find a lot of very shady sites for neuro-linguistic programming, which has nothing to do with data science or science. But again, there might be a few groups. Just check out probably on LinkedIn, Facebook. There's probably groups somewhere. I do not know if there's an international society right now. That's a good idea that Morgan said. Yeah, search for computational linguistics instead of NLP. VLang as a new programming language in data science. No idea. I haven't tried it yet. I know there's Julia out there. I know that's supposed to be very good for data science. But actually, right now, I have not had time to check out anything else that has to do with other languages apart from Python and R, which I'm still struggling a little bit with time to learning how to use it a little bit more. I'm sure that in the future we'll have to learn other languages, because that's just what happens. Can I ask about no-code platforms? Yes, you may ask about no-code platforms. They're interesting. They're very good for running some experiments with, and they might be incredibly good in the future. As I mentioned at the very beginning, I do believe that as a data scientist, your main concern should be learning statistics, learning the math behind it, and learning to code. As I said, I do recommend people learn to code, because this is a skill that you can use in other fields in the future as well. But no-code platforms can actually be very, very interesting. My biggest issue with no-code platforms right now has to do with Does the platform that give you the service, can they, are they actually checking out your data? Do they have any claim to the data? Do they have any claim to whatever models you build? And that's a whole can of worms that we're not going to open today. How should we frame our elevator pitch? Should we concepts or projects, since explanations of projects would be really lengthy? Well, actually, if you're doing a pitch for a project in a company, just start with a question. You know, what is it, the question that you want to answer? You know, like, for example, can we predict when a client is about to leave us? That's a hypothesis that has a null hypothesis. No, we can't predict this. So when you present it to the higher ups or to management, you can present it that way. You know, the project is looking to answer the question, can we predict when a client is very close to leaving us? And if we can, we can do something to retain them. So that's the value that is going to be added to the company. Can we predict the amount of how much money we can lend our clients with limited risk? Can we predict when a credit card transaction is fraudulent? Those kinds of questions. Always ask questions and start with the question. That way it's going to make it a lot easier to make the pitch. Hi, Min. Hi, Harshada. If you have any questions, just jump in.
Oh yeah, it's really great for me. Thank you for answering the blockchain question. So I'm currently in high school, so I'm really interested in data science in general. So I think at my school we are collaborating to, you know, offering normal students to get them know into data science. So do you have any advice for us that we could design sorts of curriculum for average students to actually get approached into data science effectively?
Yes, actually. Again, the main skills, make sure that people understand that how much you know about statistics, how much you know about the actual building models. But the most important part is, have you built anything? And if you haven't, build something. Just go ahead and build something. Build a model, even if it's a simple one. You participate in Kaggle competitions and then put your code in GitHub and tell people, hey, I did this. And your curriculum should be focused on specifically the skills that you have and the projects you have done. Because that's what's going to show people or recruiters what is your value or your potential value to the company.
Oh, that's great. And I also one more question is that
Sure.
I'm currently interested in distributed database system because I'm currently in a project researching on you know, building the decentralized apps in the Cardano ecosystem. There's in blockchain, but yeah, I'm still actually working on distributed database system. So could you tell me a little bit about it as your experience?
Again, my skills with data engineering are very, very limited. I understand the concepts, but I haven't actually worked in it. With distributed data systems are very interesting. I don't know a lot about them. I do know that what's becoming really interesting in data science are the data lakes, the whole data lake architecture. Specifically, now there's the what's called the Delta Lake architecture, because at the end of the day, the whole distributed concept is they're trying to unify to distribute. But again, this is definitely not my field. So I will do a disservice to the whole data lake and the whole data engineering industry if I actually started getting more into it.
Yeah, that's actually quite cool because like blockchain is about to be the trends on the upcoming years. Like it will change our financial system and, you know, a variety of fields that could actually be involved in it. So I think of it, I'm actually quite interested in data science and blockchain at the same time. So actually working out something that could relate it both. Yeah. So yeah, thank you for your response. Yeah. Great.
Sure, anytime. That's very interesting. And I do think blockchain and the whole concept of blockchain and decentralized applications has a huge future. I think blockchain is the future of many things, including the economy. But again, it's not definitely not even close to my area of expertise. But taking advantage of what we were just talking about, what is the difference between, Cindy asked, what is the difference between a data scientist and a data engineer? Again, things are changing very quickly, but a data engineer is the person that takes care of the architecture. How is the data going to be managed within the company? How it comes in, how it's transformed, how it's loaded into the systems, how people that need the access to that data are actually going to be able to access it, who owns the data in the different levels. So the whole understanding how the data distribution system works within an organization, that's the data engineer. Data scientist is the one that's going to run experiments on that data to see what kinds of models we can build in the future. Hope that answers your question. There was another one before. What would you advise if I have to build a data science team from the ground up? What should I look for to have strong pillars for my team department? I would say start with an experienced data scientist if you can, someone that understands data science as a concept, and especially how to run data science projects. That would be my suggestions for the first person, but I'm very biased because I am a data scientist. Some people actually like to start with a data engineer, or what's called today a data architect, someone that can actually build the whole infrastructure that you need to manage the data, and then bring in a data scientist that can start asking the right questions. I actually like asking the right questions before building the architecture, but again, I'm very biased on this subject. And then I'm hoping that the organization already has good data analysts, and you bring the best data analysts into the data team, and you can actually build a team with 3 or 4 people. Many startups actually only have one data scientist, and he's the whole team. He's the engineer, the scientist, the analyst, the everything, and that happens. But at the end of the day, I would say you start with a good data scientist, and specifically, hopefully, he has good management skills at the same time. I know I'm asking for a lot, but if you already have a company and the company has the budget to actually have a data science team, start. Probably for me, the core of it would be a very, very good data scientist. Is about how to minimize the risk of spending too much about data science project, data gathering, engineering resources without any valuable inside output, because data science projects can be costly. Yes, data science projects can be costly. And again, that's why when you ask a question, a business question, that business question has to have a very specific value at the end of the day. That way the company knows how much to invest in it. I mean, there's a whole thing about getting into the data science pipeline, data analytics pipeline, how to build data science projects, which we could spend all day talking about. But the most important thing, again, whatever question you ask, you have to be able to figure out what the value would be for the company if you could answer that question in a positive way. In other words, if you can prove the hypothesis, if you can actually, for example, predict the prices of stocks, which is probably almost impossible to do, and we can get sort of close-ish. But if you could actually build a model to predict stock prices, that would have a huge value for the company. If you can predict when systems are going to break down within your company, that might have a value for the company. And you have to figure out what this value might be. It's not going to be a specific number, but it can be very, very. But you can hit the ballpark. Like for example, if you're losing 10% of clients every month, and you can build a predictive model to see when they're about to leave, so you can do something, then you could probably actually convince the company that this is worth a lot of money, because instead of losing 10% of the clients, you might only lose 5, 4, 3, 2%, etc. So that would be it for me. Where are some great places to get data? Kaggle, a lot of governments have data. International organisms just like the ODCE, the International Monetary Fund, the World Bank, all of them has a lot of places to get data. And again, I love Kaggle. The only issue with Kaggle is that most of those data sets are already clean. And yes, a lot of your work is going to be understanding and cleaning data. So try and get something that's a little bit more interesting. Let's see if we can get. I don't know if I can extend the time. but I'll keep going until they tell me that I have to stop. So just to see if we can answer a few more questions. Python, R are both dynamic languages. Do you think we should more to a statically typed language in order to improve the performance of data science projects, speed up training, less type errors, development audit? Well, Ibrahim, that's a really interesting question about if we should move to more statically typed models. Probably, I don't think so. I mean, if you look at it, the Google has a philosophy on coding. Python, where we can, C where we must. So again, the dynamic models, because it's especially when you're talking about models that are going to be constantly changing, and then you want to constantly be retraining, and then you want to be adding new algorithms and new models as time goes by. I would say that dynamic languages are going to be the way to go with everything that has to do with data science. Let's see if I see any more questions. Do you use Python for data with millions of rows? If not, what is used in industry? I use Python with pandas, even if we're talking about millions of rows. That just depends on what your processing power is. Most people won't have that kind of processing power locally, but you can have a lot of processing power on the cloud. So again, it depends on how much processing power you have. I do like to use Python. Some people like to use R. It's up to whatever makes you feel more comfortable at the end of the day. And the industry, the standard right now for data science is Python. There's still a lot of work on R, but Julia and Scala and the rest of the languages, they're used on very, very specific projects, but they're not common in the industry. Scala seems to be a potential for cloud engineering. How do you think about this? No idea. I mean, I know very little about Scala, so I have no idea. And again, Python 10 years ago was an okay language. Now it's an industry standard, so you never know what's going to happen. I would just suggest keep track of the TIOBE indexes, and there are other indexes to see what programming languages are more popular at one time or another. Stack Overflow has a good, how many queries are done for a particular language. Kaggle is great. Yeah, Monica, yes, definitely. Kaggle, as the data sets are clean, and that robs you of a lot of wonderful work. And believe me, when you're actually cleaning the data, that's a great time to understand the data even further, because you start understanding how it was collected, try to understand what they meant by certain things, and start getting more intuition about the data. That's going to help you build even better projects. Mac or Windows? At the end of the day, it's the same. It just depends on what you like better. If you want to build ML projects, I wouldn't focus on Mac or Windows or Unix. I would focus on how much graphic processing power you have. If you can get I know NVIDIA cards right now are very hard to get by, and they're very expensive. Thank you, crypto miners, for helping drive the price up. But at the end of the day, it's whatever you feel more comfortable working in. Again, if you're working in an uncomfortable environment, you're probably going to make a lot of simple mistakes. So just whatever it is that you feel more comfortable with. Any recommendations for learning statistics in Python? Mike, I would suggest just learn statistics and then learn statistics in Python. You know how to for SciPy. I can't think of a book off the top of my head. But there are so many good books out there. I would suggest just going to Amazon and check out what's highest suggested for that. But before actually getting to statistics with Python, get into statistics, understand statistics. That would be my suggestion, so that you understand the statistics, the whole science of statistics, especially when you're getting into concepts that are a little bit more complex, like Bayesian statistics and probabilities and naive Bayes and stuff like that, so that you understand them before you actually, because most statistics with Python courses and books are going to tell you, oh, this is how you implement this. This is how you get this, but they're not necessarily going to give you the whole concept of why that actually works and why that is important. How to approach automation project, example, business report automation. That's I think you should ask a data engineer, because they're a lot better with approaching automation. It depends on what the organization is working on and what the resources they have are for doing automation. I honestly don't do a lot of automation myself. I just build the models and then I pass them on to my team, and if they have questions, they can ask. But at the end of the day, because our team develops in JavaScript, so they have to take my Python models and figure out how they're going to get them used in JavaScript, which they actually do a great job at it. So I don't know. I would probably want to ask one of them how to approach that automation part. But it has more to do with the engineering side of it than with the data science part of it. But again, it's important to know if depending on the company that you're working at. Does data science is doing ML as well, or just analytics? Actually, data science includes ML. I would say machine learning is part of data science, same as deep learning is part of machine learning, especially nowadays. I don't know of any data scientist that is not doing machine learning in one way or another. There are new concepts on AutoML. Could you go into details? Well, AutoML has to do with no code, with the no code concept that we were talking about before. And I actually like the concept, but at the same time, for me, the AutoML has the issues of who owns the data, who owns the models that come out of it. It's great for people to build their own models when they have very little knowledge about what happens behind the scenes, what happens under the hood. But on the other side, me personally, ethically speaking, I think that you should know what's happening under the hood before you go ahead and build a machine learning model. How do you find the client-side data science libraries, TensorFlow, JS? What are the best use cases? Wow, I actually find them very interesting, especially when it comes, well, TensorFlow and PyTorch for deep learning, they both have a very interesting client-side library, client-side plugins, especially for JavaScript. But what are the best use cases? Well, the best use cases, interestingly enough, are in Python. Just look at Google. Everything in Google is built mostly on Python, and some of it on C. And all their machine learning models are brought to you, like when you're searching Google, the autocomplete, the translate, the everything has a plugin. I'm not sure if they're using JavaScript plugins, but at the end of the day, that would probably be the best use case. I just don't know how much information you can get out of it. Product analysts perform machine learning as well. Well, generally, again, if you are going to build machine learning, you want to do a data science project. You're going to build a hypothesis before you build the model. So it depends. Is the product analyst also, do they know about machine learning? Do they know about data science? Do they know how to put together a project? Let's talk about ethics in data science. What are your limits to problems that the community won't work on building an ML solution for? The limits to problems. Morgan, I'm sorry, I don't know if I understood the question correctly. Your limits to problems that you won't work on building an ML solution for. Well, I don't think there's a limit to the problems. There's a limit on how you use them. If I understood your question correctly, meaning that if people are willingly giving you their data because you're giving them something. Oh, there you are, Morgan. So we're going to wait for Morgan to. Hey, Morgan.
Hey, Jack. Nice to meet you. So yeah, I was just going to ask for the ethics component of when we're talking about like data science and machine learning. We're all talking here about what we can do that's exciting in data science, but we also have to think like ethically from our hearts that we're building solutions for the future, right? So that's why I was talking about the blockchain and everything. What are some things that potentially, and you mentioned this earlier, for example, about the bias of the data that may go in, for example, figuring out whether or not to provide parole, right? Yeah. That seems like a very, like one would say, okay, well, we're following the law. But the reason why we have judges is because we have to interpret the law. The laws still need to be interpreted by humans. And actually, our interpretation of human actually changes over time in society as we learn new things. So I believe that there are limits, but I want to pose this to you and also to get the rest of the community here to think about what are your limits as a data scientist, as an engineer, to take on some of these problems, and where you're going to say no and push back. I know I have done in my personal career pushed back on people and said, I'm not going to work on that, or no, we can't set that as to be the target. I just want to encourage you, you share your opinion.
Got it. Yeah, for me, it's simple. How is the model, whatever model you build, how is it going to affect people? Is it going to affect them in a positive manner? Is it going to affect them in a negative manner? Is it going to have an overly high influence in their lives? Like, for example, parole. I don't think machine learning models should be used for that, at least not at this point in time, until they can prove that they can really be unbiased and that we understand how the model works inside. And there should always be a human at the end of the line that's going to help guide the decisions. But so that's my limit. Is if the model can actually be damaging to people, that's my limit. I'm not going to work on something that I believe is going to damage people at the end of the day. I like only working on projects that are going to be beneficial. So I'm happy to talk more about this just in case, because now they're telling me that it's time to end it because the stage is about to go live. So everyone, Morgan, thank you for being here. Everyone, thank you very much for joining me today. If you have any more questions, just look me up on LinkedIn. I'm always happy to answer. Thank you very, very much for joining me today, and enjoy the rest of the DS Go today and tomorrow, and